The National Electrical Code, or NEC, mandates specific requirements for bathroom circuits to ensure safety and prevent overloading. The code stipulates that each bathroom must be served by at least one dedicated 20-amp branch circuit. This means that the circuit exclusively serves outlets and electrical equipment within that particular bathroom. You cannot extend this dedicated circuit from one bathroom to supply another, even within the same apartment or condominium unit. The primary reason for this requirement is to prevent overloading the circuit. Bathrooms typically have multiple high-power appliances such as hairdryers, curling irons, and electric heaters, all of which can draw significant current simultaneously. Connecting multiple bathrooms to a single circuit increases the risk of exceeding the circuit's capacity, leading to trip breakers, potential fire hazards, and damage to electrical equipment. The exception mentioned in the query, which allows multiple outlets within a single bathroom to be fed by one circuit, does not extend to supplying multiple bathrooms from the same circuit. The exception only applies to the distribution of power within the confines of a single bathroom. The code recognizes that the demand within a single bathroom can be managed by a single 20-amp circuit, provided that the wiring and overcurrent protection are properly sized. However, combining the loads of multiple bathrooms on one circuit introduces an unacceptable level of risk. To further elaborate on the requirements, it is important to understand the concept of a branch circuit. A branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. In the case of bathroom circuits, the overcurrent device is typically a 20-amp circuit breaker located in the electrical panel. The dedicated bathroom circuit must originate at the electrical panel and run directly to the bathroom without serving any other loads outside of that bathroom. This ensures that the circuit is dedicated solely to the bathroom's electrical needs. Violations of this code requirement can result in failed electrical inspections, potential fines, and increased risk of electrical hazards. It is crucial for electricians, contractors, and homeowners to adhere to these regulations to ensure the safety and integrity of the electrical system. Furthermore, it is important to note that local jurisdictions may have additional requirements or amendments to the NEC. Therefore, it is always advisable to consult with local building officials or a qualified electrical inspector to ensure compliance with all applicable codes and regulations. In summary, the NEC prohibits the sharing of a dedicated bathroom circuit between multiple bathrooms. Each bathroom must have its own dedicated 20-amp circuit to prevent overloading and ensure electrical safety. The exception allowing multiple outlets on one circuit applies only within a single bathroom and does not permit extending the circuit to other bathrooms. Adhering to these requirements is essential for maintaining a safe and code-compliant electrical system. It is also important to understand the specific requirements for the type of outlets that are permitted in bathrooms. The NEC mandates the use of ground fault circuit interrupter, or GFCI, protected outlets in bathrooms. GFCI outlets are designed to detect ground faults, which can occur when electricity flows through an unintended path, such as through a person. When a ground fault is detected, the GFCI outlet will quickly trip, interrupting the flow of electricity and preventing electrical shock. The requirement for GFCI protection in bathrooms is based on the increased risk of electrical shock due to the presence of water. Water is a good conductor of electricity, and the combination of water and electrical appliances in a bathroom creates a potentially hazardous environment. GFCI outlets provide an additional layer of protection against electrical shock in these situations. All 125-volt, 15-amp and 20-amp receptacles installed in bathrooms must have GFCI protection. This includes receptacles located near sinks, showers, bathtubs, and other areas where water is likely to be present. GFCI protection can be provided either by installing GFCI outlets directly or by using a GFCI circuit breaker in the electrical panel to protect the entire circuit. If using GFCI outlets, it is important to test them regularly to ensure that they are functioning properly. The outlets typically have a test button that can be pressed to simulate a ground fault and verify that the outlet trips. If the outlet does not trip when the test button is pressed, it should be replaced immediately. In addition to GFCI protection, The NEC also has specific requirements for the location of receptacles in bathrooms. Receptacles must not be installed within the bathtub or shower zone. The bathtub or shower zone is defined as the area within 3 feet horizontally and 8 feet vertically from the top of the bathtub rim or shower stall threshold. This restriction is intended to prevent electrical shock hazards associated with using electrical appliances while in direct contact with water. Receptacles must also be located at least 12 inches above the floor to prevent them from being exposed to water damage. The NEC also addresses the requirements for lighting in bathrooms. Lighting fixtures installed in bathrooms must be suitable for wet or damp locations. This means that the fixtures must be designed to withstand exposure to moisture and humidity. Lighting fixtures installed directly above bathtubs or shower stalls must be rated for wet locations. These fixtures are typically enclosed and gasketed to prevent water from entering the fixture. Lighting fixtures installed in other areas of the bathroom must be rated for damp locations. These fixtures are designed to withstand exposure to humidity but are not necessarily waterproof. When installing lighting fixtures in bathrooms, it is important to follow the manufacturer's instructions and to ensure that the fixtures are properly grounded. Grounding provides a path for fault current to flow back to the electrical panel, which helps to prevent electrical shock. The NEC also has requirements for the wiring methods used in bathrooms. The wiring must be installed in accordance with the applicable requirements of the NEC, which may include the use of conduit, cable, or other approved wiring methods. The wiring must also be properly supported and protected from physical damage. In addition to the requirements for receptacles, lighting, and wiring, the NEC also addresses the requirements for other electrical equipment installed in bathrooms, such as exhaust fans and heaters. Exhaust fans must be installed in accordance with the manufacturer's instructions and must be properly vented to the outside. Heaters must be installed in accordance with the NEC and must be located away from water sources. In summary, the NEC has specific requirements for electrical installations in bathrooms to ensure safety and prevent electrical shock hazards. These requirements include the use of dedicated 20-amp circuits, GFCI protection, restrictions on the location of receptacles, requirements for lighting fixtures, and requirements for wiring methods. Adhering to these requirements is essential for maintaining a safe and code-compliant electrical system. Here are some additional points to consider. Firstly, the dedicated 20-amp bathroom circuit should ideally be home run back to the electrical panel. A home run is when the wire goes directly to the circuit breaker without any splices. Secondly, use 12 American wire gauge or AUG copper wire for the 20-amp circuit. Thirdly, avoid using aluminum wire, as it has different properties than copper and may not be suitable for bathroom circuits. Aluminum can oxidize, causing loose connections and potential fire hazards. Fourthly, ensure all electrical boxes and fixtures are properly grounded to create a safe path for fault current. Fifthly, consider future electrical needs when planning your bathroom circuits. It's often wise to install additional outlets or circuits to accommodate potential future appliances or renovations. Sixthly, always consult with a licensed electrician for any electrical work in your bathroom. They can ensure compliance with all applicable codes and regulations and perform the work safely and correctly. Seventhly, if you are renovating an older bathroom, be sure to inspect the existing wiring for any signs of damage or deterioration. Replace any damaged wiring to ensure the safety of the electrical system. Eighthly, when selecting electrical fixtures for your bathroom, choose fixtures that are energy efficient and meet the applicable safety standards. Ninthly, label the circuit breaker in your electrical panel that corresponds to the bathroom circuit. This will make it easier to identify and turn off the circuit in the event of an emergency or when performing electrical work. Tenthly, regularly inspect your bathroom's electrical system for any signs of problems such as flickering lights, sparking outlets, or tripped circuit breakers. Address any problems promptly to prevent potential hazards. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Failure to comply with electrical codes and regulations can result in serious injury or property damage. Now let's discuss some common mistakes to avoid when wiring bathroom circuits. One common mistake is overloading the circuit. As mentioned earlier, bathrooms often have multiple high-power appliances, and it's important to ensure that the circuit can handle the load. Avoid plugging too many appliances into the same circuit at the same time, as this can cause the circuit breaker to trip. Another common mistake is using undersized wiring. The NEC specifies the minimum wire size for different circuit amperages, and it's important to use the correct wire size to prevent overheating and potential fire hazards. Always use 12 AWG copper wire for a 20 amp circuit. A third common mistake is failing to provide GFCI protection. GFCI protection is required for all 125 volt, 15 amp and 20 amp receptacles in bathrooms, and it's essential for preventing electrical shock. Ensure that all receptacles in your bathroom are GFCI protected. A fourth common mistake is improperly grounding electrical boxes and fixtures. Grounding is essential for creating a safe path for fault current, and it's important to ensure that all electrical boxes and fixtures are properly grounded. A fifth common mistake is installing receptacles too close to water sources. The NEC specifies minimum distances for receptacles from bathtubs, showers, and sinks, and it's important to adhere to these requirements to prevent electrical shock hazards. A sixth common mistake is using extension cords in bathrooms. Extension cords are not designed for use in wet or damp locations, and they can be a fire hazard. Avoid using extension cords in your bathroom, and instead install additional receptacles where needed. A seventh common mistake is performing electrical work without proper training or experience. Electrical work can be dangerous, and it's always best to consult with a qualified electrician if you have any questions or concerns. Remember, electrical safety is paramount, and it's important to take all necessary precautions to prevent electrical shock and fire hazards. By following the NEC requirements and avoiding common mistakes, you can ensure that your bathroom's electrical system is safe and code compliant. If you have any doubts about your ability to perform electrical work safely, always consult with a licensed electrician. They have the knowledge and experience to handle electrical projects safely and correctly. Understanding the NEC requirements for bathroom circuits is crucial for ensuring the safety of your home or building. By adhering to these regulations, you can minimize the risk of electrical shock, fire, and other hazards. Always consult with a qualified electrician for any electrical work in your bathroom to ensure compliance with all applicable codes and regulations.